Hello, Owls. Today we are going to be doing some ACT prep dealing with mathematics, specifically counting and probability. To make sure we're going well, make sure students you have muted your computer, and teachers, please turn up the volume of your projector. Here we go. First question is, how many ways can three people line up? And this is thinking that we have person A, person B, person C. Well, person A could go first, right? Or person B could go first, or person C could go first. That's a total of 6 ways. Now, while this is not too bad, what if they had instead asked not 3 people, but maybe 20 people? That could take a lot to get there. So there's a much quicker way to do this, right? If we're dealing with 3 people, what I do is I draw 3 blanks. And my question is, how many ways can I put a person in the first blank? Well, there's 3 people to choose from, right? How many people could I choose to put in the second blank? Well, someone's already going first, so there must be just 2 ways. Well, someone's gone first, someone's gone second. There's just 1 person left to go third. We multiply these and we get 6. That's the way we do this. So let's look at an ACT question. We're talking about salads and dishes at the cafeteria, and it looks like that we have a couple different choices. We have sandwiches, soups, salads, and drinks. Well, there's 3 different sandwiches, 3 different soups, 4 different salads, 2 different drinks. If we multiply those together, we would have 72. That's the way this counting works. It's kind of like we're counting without really counting. Now it's going to be your turn. Okay, so we have 3 things going on, right? They're going from town to the village, and then they're going from the village to the waterfall, and then from the waterfall to the camp, right? Well, if we're reading here, there's 4 ways to go from the village, from the town to the village, and there are 2 ways to go from the village to the town, and there are 6 ways to go from the waterfall to the camp. If we multiply these together, we will wind up with choice J of 48. Hopefully you did the same. Okay. Here's a slightly different one, right? This one's dealing with 8 digits, right? We've got 8 digits that we're dealing with here. So there's 3, 4, 5, 6, 7, 8. And we're told that the first digit must be an 8. Well, there's only one way to pick the number 8, I believe. It does say the other 7 digits are any number from 0 through 9, and the digits can repeat, right? So that means there are 10 different digits that can go there, right? Numbers 0 through 9 are 10. Well, if I'm looking at all this and I multiply all these out, we will wind up with choice number C, 10 to the 7th. Not too bad, right? Again, putting in blanks for all the pieces. The next question is yours. Okay, so in this one, we're dealing with 4 pieces. We're told the first 2 pieces are letters from A to Z, and the second 2 pieces are numbers. And we're told that the letters and the numbers can be repeated, so I could think about the numbers being 10 choices, right? Which automatically tells me can't be those 2. What's weird is the first letter cannot be the letter O, right? So there's only 25 letters we can choose from the alphabet because we cannot use the letter O first. Now the second digit, or second letter, I guess, in this case, can be any of the numbers, right? And we can repeat these. So there's 26 choices there. So the answer is C. Notice the distractor letter A is thinking that maybe someone did not see about this letter O. Okay, so that's counting. The next piece I want to talk about is probability. Think about probability being a fraction, where it's always the target over the total. So, for example, in this question here, we have a total of 10 pieces of candy. So it's over 10. Now the target is what we're looking for. And in this case, they want to know that we're picking things that are not great. Well, there's 4 lemons and 3 strawberries and 1 cherry. If we add those up, we will end up with 8/10, which is not a choice, but if we reduce that to 4/5, we do see the result right here. So probability, it's target over total. I want you to work the next one. Okay, this one's kind of interesting, right? And I'm going to kind of go through some mistakes first. You might just read it quickly and say like, okay, there's 35 members, so we're picking 1 out of 35. The answer would be H. That's really not correct because we're told that it cannot be any of the 3 officers in the club. So some people might think, well, okay, can't be one of the 3 officers in the club. So if there's 35 members, take away the 3 officers. Now there's only 32, and we're picking 1 out of the 32. Got to be a letter K, right? Be careful with your reading on this, right? That one was a little bit tricky. And for number 2, it's kind of a bit of a stinker as well. Okay, on this one here, we'll be looking at a table, and I want you to give it your best shot. All right, we're trying to find the probability that we're picking something from this batch is type 1 and manufactured by company B. Well, here's type 1s, here's manufactured by company B. I believe 30 is our target. We're trying to pick 30 out of how many total? We're told 100. So 30 over 100. I see the answer choice there. It is letter A. And yes, I know it's not reduced, but that's the way this one was. Okay, this one's a little different. I want you to give it a try. Okay, so we're trying to find the probability that the star is on top. Now this is a 6-sided die. We're getting 3 different views of it. So I really need to draw out what all 6 sides look like. And we're told right here what one side looks like. There's a square, a circle, and a star. If I look at the middle one, I'll see that, oh wait, there's actually 2 stars. And if I go to my last piece here, I see 2 triangles. And if I look at this, that's a total of 6 pieces, right? There's 6 sides. And if the star is going to be on top, the target is 2 out of a total of 6, which we do not see. But that reduces to be 1/3, which we have. Okay, one more, and I want you to do this one as well. Okay, we're trying to find the probability that Chris will draw 2 of the blues, right? Well, target over total. There are 12 gumballs, and 5 of them are blues. So the probability of getting 1 of the blues is 5 over 12. Now we're told that it's without replacement, probably because Chris is busy eating them. What would be my next probability of getting a blue? Well, the target now is going to be 11, right? Because there's 1 less, right? We had 12 blues. Now we had 12 gumballs. Now we only have 11. And in terms of blues, we had 5. Well, now we only have 4 left. So this is what our setup would be. And if we look at this, it is letter K. So probability, you could expect to see right around 3 to 4 questions on the ACT dealing with probability. And for the ones that we're counting earlier, you can expect to see from 1 to 2. So in terms of these 2 ideas, could be as many as 6 questions out of the 60 math ones. So time today was well spent. Hopefully you got as much out of it as I did. Thank you so much. See you all in the hallways.